This video is going to get you started running this instrument, which is the same instrument as the GC-FID, the Agilent 8890 GC, but instead of an FID detector, it has a mass spectrometer, an Agilent 5977 MSD single quadrupole electron ionization source mass spectrometer. As with any instrument that requires gases or fluids for that matter, the first thing you're going to do is check the gas levels. Go over to the regulator, look at the level in PSI on the gauge on the right. Here we're at a little bit above 500, so at this point you would want to tell me or mentor we need more gas. Anytime you're getting near 500, that's when we want to think about starting to change the tank. This is the helium gas, and you cannot run this instrument without the helium, the carrier gas. After checking the gas, you're ready to load up your samples in the sample tray over here. Now, do not put your hand past that bar if that robot arm over there is moving, or if it looks like based on the software that it is about to move. Let's look at where we're putting our samples within these trays. So here we have tray 1, tray 2, and tray 3. Within those trays we specify position, so this would be tray 2, position 1. It's pretty easy to confuse spots when you're in the middle of a tray. So let's consider this spot that I've highlighted in purple right here. Take a minute and ask yourself, what tray and which position is that? Note that this vial is in tray 3, position 24, not position 25. One final note on vial positions is that I have been calling these trays, and I will continue to call these trays. In the software, these are referred to as racks. So instead of tray 1, 2, 3, it is rack 1, rack 2, and rack 3. With your samples placed in the tray, you're ready to open the software. It's going to be this GCMS online over here. It should already be open though. So you click here, and to verify that you're dealing with an online version, you should see something in here that's kind of green. If no one's running, it should say idle and ready. And you should see all the temperature readouts and the different readouts from the instrument. If you don't see that, you could be in an offline version and you can't run things from the offline version. All right, so we've got method sequence up here that we can mess with. We are going to load a sequence. So in your folder, you should have a folder with your name within the projects checkout. So there's mine, Kenyon. Within there, you're going to want to get started with a starter sequence. It's probably going to have your name and starter sequence. So don't build one from scratch if you don't have to, but load up a starter sequence, and then you're going to say edit sequence. And I'm going to go ahead and do a zoom here so you can see what we're doing. And this data file, that is the actual name of the file that's going to go on the computer. Do not use any special characters. Underscore and dash is fine. No periods, no slashes, nothing like that. Nothing fancy. No periods, no parentheses, nothing. Keep it simple. In the name is not a file name in Windows, so you can kind of put what you want there. Also, the comment is really nice. The comment is just text that you can use to fill in what you want there, and that is not a file name at all, so you can put in what you want. Okay, so after you've given the data file and the name, you need to say where that data is going. So you want to go into the folder under checkout, projects checkout, that is your name. You want your data to go in your folder. After that, make sure you pick the correct vial position. So again, you can pick rack 1, 2, or 3. Here I'm selecting rack 1 or tray 1, and my blank is in vial 1, so I'm going to leave that there. Next, we have to select the method. You have an example starter method in the folder with your name, you should. So you select that folder, and then within that folder that has your method, your name, select your starter method. And later on, if you make other methods, you'll pick that one. All right, now from here, I want to add another sample. So I'm going to click New Sample up there. You can see that in the zoom. And one thing I can do is I don't want to have to start a list again, so you can actually say Fill Down. You can click on the Fill Down button here. If you highlight both rows and say Fill Down, and that'll fill everything in for me, because for me, this is mostly going to be the same. But instead of atropine blank, I'm going to run the atropine here. And I'm going to remember to not put any special characters. If I want to do something like that, I can put it in the name. So for example, here, I can go ahead and put in, All right, so I need to change my vial position to 2. I'm still in rack 1, so my positioning is correct. I'm using the same method for my blank and for my sample, which is what you should do. But I can put a little more detail in here. This isn't a methanol blank for atropine, but I can put in special characters like the slash in mg/ml, which I would never put in the file name. I can put that here, and it should show up in my data file. All right, so I'm going to hit OK here because I've got everything programmed in nicely. And then I'm going to go ahead and save my sequence as a new name so that I don't overwrite the starter sequence. Go ahead and hit save. Now it's got a new name, and that one is loaded into memory. And then at this point, I'm ready to go, and I can say run sequence. Click run sequence again there, and it should start running. And there was a subtle change up there. I'll zoom in on it. When it's running, it should switch to say this sequence, atropine sequence KME, is running. One suggestion I would make is, and I really should have done this with my file names too, I would put your initials after everything. I would put your initials after method, data file, and sequence file names. It'll help avoid a lot of confusion when you start appending sequences later. So this guy is running now, and every once in a while something will pop up. Usually, so it's getting ready. It's not quite running. Do not hit override. You saw that pop up right there, and it said override. Don't hit override for anything. I'll show you in just a minute that the filament delay override is going to come up. Do not override the filament delay. Don't override ready. Just ignore those pop-ups and let them do their business. If it's a real error in a pop-up, then please do notify me or one of the mentors. But most of the pop-ups that are routine are just going to be, I'm doing this thing, do you want to destroy everything and override stuff? And the answer to that is no, I don't. So just don't push anything and let it continue about its business. So here we see another pop-up that will come up every time you run GCMS, and it's asking if you want to override the solvent delay. No, you do not. You can click no, but it's best to just leave it. It will go away after the solvent delay is done. You can change the solvent delay in the method, and you may need to depending on the solvent, but the important part is you should not have the filament peak on when the solvent elutes. That can damage the filament and cause downtime on the instrument.